Hi there. So this is a video about probability. We're going to be looking at the law of total probability today. This is part of the conditional probability stuff that we were just doing in class. So let's start with the problem just here. In a particular school, 55% of the students are male and 45% are female. Of the male students, 13% say tea is their favourite drink, while the female students, 18% of them prefer tea. Okay, you'll notice up here I've got a formula box up in the top right there. There's the box with the formulas in it. So you've got the multiplication rule of probability that we saw in conditional probability, and then underneath we've got the law of total probability, which looks like a little bit complicated and intimidating, but actually when I show you where this comes from, it makes complete sense and is actually quite straightforward. The way that I'm going to show you where this comes from is by thinking about this problem in terms of a tree diagram. So I'm just going to get a pen and we'll do a tree diagram for this. So we've got a school. Usually for tree diagrams, we're talking about multi-stage experiments, right? You have stage one, something could happen. Stage two, something could happen. For us, stage one is whether our randomly chosen student is male or female, right? So stage one tree diagram, we've got male students or female students. So male and female, and then the associated probabilities just get written on the branches there. So you've got 0.55 for male because 55% of them are male, and females 0.45 because 45% are female. Okay, and then depending on whether they're male or female affects how likely they are to like tea as their favourite drink. So of the males, the people that prefer tea are 13%, so that's 0.13 of the number of people that prefer tea, the probability of preferring tea. And if you're male, the probability you don't prefer tea is the rest. That'll be 0.87. Like that, 87% of students. For females, there's a slightly higher probability that you like tea if you're female in this particular school. So females that prefer tea are 18%, so that's 0.18 on that branch. And then don't prefer tea is 0.82, right? And you'd be familiar with using tree diagrams to work out probabilities. You can multiply along the branches, and it gives you a really neat way to enumerate all the different ways of getting a particular combination of outcomes. So if we want the probability that a student chosen at random prefers tea and is female, we would go along the branch for female. That would be 0.45. So just by doing the tree diagram here, we do 0.45 times 0.18, right? I'll grab my class pad and we'll just write down that probability there. Okay, so 0.45 times 0.18 and hit execute. So we've got 0.081 is the 0.45 times the 0.18. 0.81. Nope. 0.081. Let's get it right. 0.081. Okay. Just by multiplying along the branches. Now, if I were to look at just up here where you've got the multiplication rule of probability, we could use the multiplication rule of probability to do this, right? So in probability A, part A, probability that we've got female and prefers tea, yeah, is the intersection, isn't it? That's the intersection of the two things. Just using that thing up there, that's the probability of preferring tea given that you're female multiplied by the probability of being female, and the probability of preferring tea given that you're female is just that 0.18 there, 0.18, and you multiply that by the probability of being female, which is 0.45, and that's exactly the same multiplication that we did before, yeah, just the other way around. So you've got 0.18 times 0.45, and we arrive at 0.081 still. So that's the multiplication rule of probability that we would have been doing in class last lesson. The next thing that we're going to look at is the law of total probabilities. What's this all about? Well, if we've got a situation where we've got some conditional probabilities that we've been given, and we want to know the probability in part B, for example, that a student chosen at random prefers T. So regardless of whether they're male or female, just that they prefer T. Okay, so we've got in part B then, what we want is the probability that a randomly chosen student prefers T. All right, looking up at my formula box there, I've got the probability A equals probability of A given B times probability of B plus probability of A given not B times the probability of not B. Sounds complicated. Let's just pause for a second and try and solve this problem using the tree diagram, and then we'll look again at the formula and see if it makes any sense from there. Okay, so to the tree diagram then, we want to know the probability that I randomly choose someone and they prefer T. So the people that we're interested in are the people at the end of this branch here, so this bit here, and then you could also be male and prefer T. So it's that bit there that we're interested in. I've already worked out that it's 0.081 along that set of branches, and to get the number on the top set of branches, we've just got to do 0.55 times 0.13. So I'll just quickly do that, 0.55 times 0.13, do that. 0.0715 is what I get. So 0.0715 there. Just going to double check that I've not misremembered that. Yep, that's right. Okay. And with a tree diagram, we just add up the things at the end of the tree that we're interested in. So for this, I would then do those two things added together. So I've got 0.0715 add 0.081. So let's move that up, plus 0.081. We get 0.1525. That is 0.1525. All right, 15.25% as my probability here that you randomly choose someone and they like T. Easy enough on a tree diagram, but if we wanted to use that formula just there, well, let's just look at what that formula is saying. It's saying the probability of A given B times the probability of B. Well, that first part of the formula there, yeah, is just that, isn't it? So what it's saying is you get the intersection of A and B, and then add to it the intersection of A and not B, right? Which is kind of what we're doing here. We get the people that like T and are male, and add to it the people that like T and are not male. Okay, so like if I work that through, it would just be 0.13 times 0.55. You know, A given T given M times T times M. Sorry, multiplied by. Then I go down these branches, don't I? So the probability of T given F, which is 0.18, times probability of F, which is 0.45. And yeah, if I work all that out, so 0.13 times 0.55 plus 0.18 times 0.45. Execute, I get the same answer that I got before, because it's the exact same calculation, really, isn't it? That just shows you where that comes from. Okay, 0.1525. So a tree diagram is something that we're familiar with, and it makes this formula make sense.